Hello, welcome to Introduction to Business Analytics, really. But in this class, we're going to take more of a marketing analytics spin. In previous version of the class, I went for more of a financial analytics angle, so I thought I'd change it up and do kind of a new domain knowledge of how you can utilize analytics. Many of the techniques in this class that we're going to use are you can use them in different domains, be it, HR analytics or finance analytics, but I just thought it would be more interesting to look at some new topic matter. Anyways, so this presentation is going to provide the background knowledge for our future discussions on analytics. Also, it's going to have the topics covered in homework 1. So the way I've designed this class is the online lectures that I post should give you the background knowledge or theoretical knowledge and are all associated with the online homeworks associated with McGraw-Hill. The in-class stuff we do are going to be more applied and activity-based. So how do you actually use these softwares and how do you actually do this stuff? But your grade will come from the homeworks and final exam, depending on if you're undergrad or graduate, uh, based in McGraw-Hill. So hopefully this class setup will meet everybody's needs, regardless if you're taking it in person, live streaming, or taking it purely online. All right, so let's get started. So we all experience the results of analytics in our lives all the time in different ways. The questions on this slide are just a very small example of the questions that are answered using analytics. And since this is going to be marketing analytics based, these are going to be more marketing based questions. But there are so many questions that you can answer with analytics. So in this presentation, we look at some of the underlying themes and concepts related to analytics. In particular, like websites, Expedia, Orbitz, Hotel.com, etc. Cheapo Air, whatever you're using to buy, a hotel, airplane flight, etc., or any other kind of online shopping. How do those websites take the data from usually your search data and develop marketing campaigns based on the analytics to make you more likely to spend money on their site? Or, you have Spotify or similar, Pandora, etc., all the different music venues. How do they suggest which songs to play to you? Now, most of them, in my experience, don't do a very good job. So a lot of the underlying algorithms could probably use some work. And, how do we Stitch Fix achieve the highest ever rate of purchase items per fix for its female customers? Um, so we'll get to each of those kinds of domains from an analytics perspective. So marketing analytics uses data, statistics, mathematics, and technology to solve marketing business problems. Modeling and software are used to drive these decisions, used to solve the business problems. So the growth experience in this field is primarily attributed to social media data, which is used to gain insight to customers' behavior. So all the people out there who use social media, Facebook, a decade ago, Twitter, Snapchat, Instagram, etc. All that data is being collected, and the reason those services are in general free is because they're taking all the data about you, selling it to a marketing company, and then using that to better market to either your IP address if it's a computer or your IMEI number on your phone. I think that's the right number. But you can see that based on this chart here, who is utilizing analytics the most? At the very bottom, we have supply chain analytics. It's kind of surprising because, especially in the past couple of years, we've had so many supply chain issues. It seems like we could really utilize some more analytics to solve that problem, or logistics. And here in Jacksonville, it's kind of interesting because we have all the shipping right there in the river and other logistics companies around the Jacksonville area. Just above that, we have HR analytics, which provides kind of examples when you send your resume for a job, the analytics behind how, it probably doesn't even get seen by a real person before it's been filtered a million times by a computer based on keywords, etc. That's kind of more natural language processing, text mining, which I think we'll talk a little bit about in this class maybe, or at least in one of the future classes you have with me. And above that, financial analytics. I'm surprised this is as low as it is because with algorithmic trading and all the analysis used by banks and traders, it seems like I would have expected that would have been the highest. But no, you can see this line here. Marketing analytics is utilizing analytics the most of any field, and it basically comes down to the fact that they'll take your data from any source, driving records, your car records, anything they can get from a public source, and then anything they can pull from social media or your browsing history, and they can market to you the best. So they're the ones who are paying the most for that data, and they pass that cost on to you and the products that they sell. But it's probably one of the best domains for learning analytics because there's so many ways you can actually apply this. So analytics involves simple techniques like descriptive statistics and data visualization, but primarily focuses on more advanced techniques including predictive, prescriptive, and the new buzzword, artificial intelligence analytics or cognitive analytics. So I'm going to talk about each of these in more depth throughout the course. But you have descriptive analytics, that's very basic information about mean, median, mode, range, the descriptive statistics, as well as data visualizations. So a lot of this is very low level analysis. Easily do it in Excel. Then and data query, so that's like SQL databases, which you'll have another class with another professor on. But that's kind of this very low level, low paying level of analytics. Then you kind of move up to predictive analytics, and this is where you'll start to find jobs that pay a little bit more money. And I find that the analytics is a little more interesting because there's actual decisions you can make on this kind. So you have like forecasting, that should be pretty self-explanatory. You can use like simple regression or something, and you have some data, and you want to predict something a little further out in the future based on the data you have. Other predictive modeling, and a lot of it's regression based, but you have a lot more classification type algorithms where you can it's going to put it up here, but there's predictive level classification algorithms. You can do logistic regression, support vector machines, neural networks. That's going to can be used for prediction. Cluster analysis is more like unsupervised learning, which we'll talk more about in the future, where you try to cluster things together. This is done a lot in marketing analytics. When you get to prescriptive analytics, that's going to be more like operations management, optimization modeling, linear programming, and other kinds of decision analysis. If you're taking other classes at Jacksonville University, DSIM 305 is our kind of required class for undergrads and it should focus kind of on this kind of prescriptive analytics. And then finally, you have artificial intelligence, cognitive. This is a big buzzword in the past bit of time, and had a kind of a stock market bubble associated with this. But this is basically using very, very powerful computers to see patterns in data that we wouldn't be able to do just to the sheer size of the data, big data, as well as utilizing this concept called deep learning, which is really just using very, very large neural networks to solve these kinds of problems. So you also have this fall under with natural language processing, text mining, and other things like that, but that's going to be kind of in that artificial intelligence. So the analytic levels, so this is kind of a recap of what I was talking about, or maybe a little more concise. So descriptive analytics are techniques used to explain or quantify the past. Um, predictive analytics is used to build models based on the past to explain the future. Prescriptive analytics identifies the optimal course of action or solution, and then artificial intelligence are designed to mimic the human-like intelligence for certain tasks like discovering patterns. The underlying analytics uses machine learning. Usually we think of artificial intelligence and machine learning as kind of synonymous. It's actually kind of funny to think back. Machine learning first started kind of in the 80s, but the computers weren't powerful enough to run a lot of these algorithms like neural networks. So they weren't super popular or important for almost, I don't know, 30 years. And it's only been in the past like 5 or 10 years that a lot of these algorithms have come back because we have the computers that have the power to actually run them and make good use of them. So defining the right business problem. So this is kind of the stages of analyzing, any problem. You have to understand the correct problem before you can solve it. So analytics should always start with gaining an understanding of the business problem that needs to be addressed. Identifying the problem allows the company to discover business opportunities, but understanding is not easily gained or measured. It really comes down to using a scientific method to define the problem. So we have several steps. Understand the problem, you know, from a marketing angle. How are they searching for the product they're interested in? Where are they going to purchase it? And their satisfaction levels. So if you think about like Amazon, you have the 5-star levels, or other websites, what is it, like Booking or whatever, it's rated from 1 to 10, etc. So they want to make sure that you can find what you are looking for, that you're going to purchase from them, and then they're satisfied so other people will buy from them. So problem identification uncovers strategic business opportunities. The goal of basically all businesses is to improve market share. So they want more customers. They want their 10K to show that they're meeting their goals, and their stock will go up because it comes back to they're trying to keep their shareholders happy basically at all costs. So to establish a better customer relationship, they need to keep their customers, so you'll keep giving them money. That's kind of the underlying theme of marketing. And to position the company to take advantage of innovation. So that's where the kind of the technology aspect comes in. So how do you arrive at the right business problem? You have to understand the intent behind the question. So this is you as an analyst, you're talking to the stakeholders and trying to make sure that you understand what it is they want and interpreting what they say into something that's actually actionable. So of course, include the stakeholder input through the discovery methods, and discovery begins with what, who, where, when, why, and how. So, very basic questions for. So this table shows the different questions that can align to different business problems. Clearly, identifying and defining the problem is the most important step in analytics. Just some sample questions. Say you want to find the underlying context of this. You can, if a problem has occurred, you could say, well, what happened? What is the current problem we're trying to solve? You just at the early stages when you're talking to the stakeholder, as the analysts, it could be people in another department or higher positions than you, and your goal is to just understand the context of the problem. Um, and of course, after you figure out what the problem is, you want to say, well, why might this have happened? So root cause analysis, what caused this to happen? And then developing a timeline when the decision needs to be made, because you need to know how quickly you need to find the solution and get this into the hands of somebody who's actually going to make the decision. And good idea to know who your stakeholders are and kind of what they're expected, what is the anticipated return on investment for solving this problem, because generally they want the cheapest solution that saves them the most money or makes them the most money. Right, so the SMART method is a good goal setting method that is useful when defining goals to be solved using analytics. Making goals specific, measurable, attainable, relevant, and time-based is what allows analytics to be successful. Failing to define a goal properly makes results difficult to obtain and implement. So I think there's a homework question associated with the letters and what they stand for. So pay attention to this slide. Okay, data sources. Data sources can be either primary data that was collected for a specific purpose, or more often, as an analyst, you're going to use secondary data, which is data that already exists. You can pull it from the internet, or it's something somebody else collected, and now you need to utilize it to make a decision on. So secondary data is good for many purposes and can assist with generating ideas to ask the right questions. There's a few other examples of where you can get secondary data. Primary data is sometimes if you're going to develop your own survey or interview, people to get the kind of information you're looking for. But generally on a larger scale project, you're probably going to use secondary data that you can pull from multiple websites or government sources to get the kind of information you need to develop a model. Now, types of data. So data can be structured or unstructured. Hopefully you've heard this terminology before. Structured data is organized and is much easier to analyze, although often needs to be cleaned. Unstructured data is more difficult to use and includes text, images, and videos, which if you think about the kind of environment we're living in, that's more likely going to be the kind of data that we're working with, right? All the social media data, all the memes and pictures with text on them, and trying to divide that down, or trying to analyze TikTok videos, etc. Analytics has gotten much harder, and later we'll understand why we're using those kind of artificial intelligence techniques to understand more about our customers from this kind of unstructured data. So more and more data is coming in unstructured formats, and analytics techniques have been developed to enhance that kind of utilization. So we're going to talk about different kinds of variables. We'll talk about this in a little bit deeper in our actual live session as we're applying it to different kinds of software such as Python. But here we'll start with just very basic kind of numbers. So variables can be numeric or categorical. Numeric data can be discrete and whole numbers or continuous values with decimals. Categorical data has values that are in categories. Binary has two values, likely yes or no, 1, 0, etc., on, off. Binary is very important because a lot of the classification algorithms we're going to work with in the future are going to have binary dependent variables. So just kind of remember that terminology. Nominal is an interesting because it has no meaningful order. So let's say you had, 4 groups of people, and they called them Group A, Group B, Group C, Group D. But if you called them Group 1, Group 2, Group 3, Group 4, those numbers are nominal numbers because there's really nothing. It's just a label. So those numbers might as well be letters, right? Because the numbers don't actually represent a quantity. So we call this nominal. Now, the next kind is called ordinal. So those data has meaningful values. So now if we say 1, 2, 3, 4, or for group 1, group 2, group 3, group 4, then that would be like their places in a race or something. So the ordinal numbers have an actual value that means something, as opposed to nominal where there's no meaningful order. Ordinal is also something you'll see in Likert scale surveys. So when you have, very unsatisfied to very satisfied, you'll often see, 1, 2, 3, 4, 5, where 5 is most satisfied and 1 is least satisfied. So those numbers have order, and that data has meaningful values. Predictors versus target variables. So analytics uses independent variables or predictors to determine the impact on independent variables. So what does this mean? So this terminology is pretty important. In general, the dependent variable is what we're going to be trying to predict, right? So if we develop a regression, or let's say a logistic regression, so that's binary logistic regression, and we want to know basically, is it going to rain today or is it not going to rain today? So we have two outcomes, two outcome dependent variables. So let's say 1 means rain, yes, and 0 means rain, no. So we're going to take a whole bunch of independent variables, that could be weather patterns or whatever, just anything that we can use to try to predict that. And then we're going to throw that in an algorithm such as logistic regression and predict whether or not we think the weather is going to be rain. And I think in this instance, the weather conditions on ice cream cells. So that would be a continuous value. So how many cells do we think we can make? So that would just be a regular simple regression or multiple regression probably. So variables are characteristics or features that pertain to a person, place, or object, and the weather conditions are the independent variable, and it influences or drives the dependent variable outcome variable, which will be ice cream cells in this case. So modeling types, supervised versus unsupervised learning. I mentioned this concept a little bit earlier, but in modeling, we can use supervised or unsupervised learning. Supervised learning has a known target variable, and a training data set is used to learn about the relationship between the variables. A validation data set can determine the accuracy, and the testing data set evaluates the model. So when we get to actually calculating these out, well, if we have data to work with to train the model, we'll break that down into a training data set and a test data set. So we'll train the model with the training data set. Say we split the data that we have 70-30. So we'll use 70% of the data to train a model. And after we have the model trained, then we will test it against the test set, which is the other 30% of the data. And that way we can calculate measures such as accuracy, precision, etc. We'll talk more about how you measure the quality of models later. But that's an example of supervised learning. So it's kind of like the example with the ice cream sales or the predicting the weather based on logistic regression. So we have data to work with that we can use to predict something. On the other side, we have unsupervised learning. We may have data on this, but it's not labeled. We don't know anything. We don't know too much about it. So with unsupervised technique, we basically we just send the algorithm out and we let it make decisions on its own. So like cluster analysis down at the bottom. So if you have some data and there's different nearest neighbor algorithm, it'll say, well, these two dots on a scatter plot are similar, so let's cluster them together. And these dots over in this other corner are similar, so we'll cluster them together. But that's kind of some examples of the differences between how we use them. So unsupervised learning does not have a defined target variable, and the goal is to discover patterns to generate insight. So unsupervised learning includes many methods we will discuss later in this course. Like I said, cluster analysis is something we'll get to later. So this shows the 7-step analytics process, which includes understanding the problem, collecting the data, preparing the data, developing the model, evaluating the model, communicating the results, and then deploying the model. So on the following slides, we will look at each of these steps in a little bit more detail. So the first one, business problem understanding. So most analytics models are developed to solve a problem. Clearly defining the problem is a key part to performing the right type of analysis to create an appropriate solution. So to determining if the problem is the correct problem to address the needs of the organization is key. In general, we want to find out exactly what are you trying to understand and solve, how will the stakeholders use those results, who will be affected by the results. So is this a single or short-term problem or an ongoing situation? So those are just some questions as they're just trying to understand the context of the problem, who's going to be affected, and then you start to use maybe previous experience to see how can you move this process forward. So next, it is important to identify where the data is stored, what format is it in, how it can be used to address the identified problem. This is often a problem because once you have the data, you may see various analysis that can be done, but if it doesn't answer the question or provide the solutions to the problem, it may not be the correct analysis. So the type of data you can obtain may also determine the questions that can be reasonably answered. You cannot always get the exact data you might need to solve the problem, and determining that early in the analysis and making realistic goals for a business is important. Okay, data preparation is often the most time-consuming step of the process. Data is combined and the target and predictor variables are identified. The data needs to be visually inspected and it must be cleaned to deal with missing values, errors, or values that cannot be dealt with or analyzed as they are, as well as outliers. When data comes in from other sources, it is often doesn't merge in a consistent format and has to be corrected before analysis can be performed. So this is what we call with like data wrangling, data cleaning. Very rarely are you just going to be given, an Excel file that's in perfect format that you can just run. And honestly, data cleaning is generally the longest step in an analytics process because getting it cleaned and ready to run in an algorithm is time consuming and generally just a pain, really. Anyhow, so modeling development. When developing the model, the analyst needs to determine what method is best to address the business problem. There are many options for analysis that we will discuss in the class and beyond to help you determine what is the best choice in a given situation. Different models can be tried and the best one selected, which should be simple, practical, and useful. So a lot of what we will do in this class and future classes once we get to it is we'll have data. Let's say we're trying to classify uh, whether or not a loan is going to be defaulted. That's a common data set that we work with in this program. And then what we'll do is we'll run several different algorithms on the data, and whichever one has the highest predictive power, specificity, accuracy, we would select to use that algorithm, and then we would deploy that model to help make decisions. So that's where we get to this model evaluation. So after performing the analysis, the model needs to be evaluated and interpreted. You will first validate the model, and then if it is appropriate, you can move on to the next step. If it does not address the problem or has poor results, you would need to return to the previous step and develop a new model. So that's kind of the cycle that we run through. We prototype different models, and then we try to find the best one that solves the problem that we're trying to do. All right, the next step is to present the model in a way that makes it easy for people to understand, as easy to learn advanced terminology, and then use it in the presentation of the results, but is not a good way to communicate it to others who will not understand. Presenting it in a straightforward way without including code and using simple visualizations is best. Because in general, as an analyst, you'll go into a meeting and you will know a lot more about the problem, the data, etc., and the different kinds of models, and trying to present to CEO or CFO or something, they're not going to completely understand all the background of what you did. They just need to know basically what it is they need to do with what you're giving them. So using simple visualizations is best. Something if you can't immediately understand what the visualization is saying, then you should probably use something else. Never present using code, because throwing some code up on a screen, nobody's going to understand it unless you're in a room full of programmers, but that's not generally going to make the stakeholders happy. Right, then you have model deployment. The last step is to implement the model once everybody's okayed it. So you put the model into real time using real-time data to provide decisions and recommendations for actions. These recommendations are the insights of the analyst that make the job essential, as those business insights are what make your analysis unique. Setting yourself apart. So there are many software programs used in analytics, and we will look at a few, trying to focus on those that are most commonly used. In the last couple of years, Python has become the most commonly used, but it is ever changing. So I suggest you look at jobs and find the ones that interest you most and identify the types of software they are using so you can begin to learn something about them to align yourself to those jobs. We will cover several of these in more details in this class and in the next few if you're an analytics major, as well as some of the other classes that you won't take with me. So in this class, we'll talk about, in general, Python, RapidMiner, R, and Excel. Anaconda is actually part of Python. Should have not put that there. SQL is another class, and you'll probably learn some, let's see, some other things from the other classes with the other professor that teaches the other analytics classes. But there's lots of software we're going to work on, but we're kind of try to focus more on Python since it's become the most popular. R is also pretty popular. RapidMiner I like because it's better for visual learners, so people that don't like coding can use RapidMiner and still learn like the underlying processes. But we'll talk more about that in the future. So this ends the presentation on Introduction to Business Analytics, which covers the topics found in Homework 1.